Grade 6, Revision 1. Translation. You see this point? It's at 0. If we add 2, it will move 2 points to the right, so it will be at 2. Okay, after we have added 2, we can subtract 4 now, so it will move 4 points to the left, and it will be stable at negative 2. Okay. Let's take this point at the coordinate plane, which is stable at 1 and 1, 1 and 1. So we have the x value is 1 and y value of 1, and there is no motion here, and the point is 1 and 1. Okay, what if we want to move this point 1 point to the right? So the x, we will add 1 to x, so the value of x will be 2 and the value of y will be 1. So the point will move 1 point to the right, it will be at 2 at 1, 2 and 1. So here is the new point at 2 and 1. Okay, what if you want to move the point here 4 points to the left? So you'll subtract the x value by 4. So the new value of x will be negative 2, as 2 minus 4 is negative 2, and the y will remain the same as 1. So we'll have negative 2 and 1. So the new point will move here to negative 2 and 1. So if you want to move the x value 5 points to the right, so we will add 5 points to x value, which is negative 2. So negative 2 plus 5 will be 3, and y will remain the same, which is 1. So the new point will be 3 and 1. So the point will be here, and it will be 3 and 1. Okay, we have to move the point 5 points up now. 5 points up. So we will add 5 to y, and the x will remain the same. So the x will stay 3, and the y will be 6, as 1 plus 5. So it will be 3 and 6. Okay, it's 3 and 6. Okay, so if you want to move it 10 points down, you will subtract 10 from y. 6 minus 10 is negative 4. So the new point will be 3 and negative 4. So the point will be here. 3 and negative 4. Okay, and the last translation we made, we have 5 points up. So we have negative 4 plus 5 for y. So we'll have 3 and 1. So the new point will be 3 and 1 here. Okay. Exercise 2. Now we will move this figure 2 points to the right. We will start by negative 5 and 0, the first point here. So we have negative 5 plus 2, because we will move it 2 points to the right. So we have negative 5 plus 2, it will be negative 3 and 0. So the new point will be here. So, okay, let's see this other point here, 5 and 0. We'll do the same. We have 5 plus 2, and it will be 7 and 0. So the new point will be here. We can move it here, 1, 2, 7, and the last one we can do it in a different way here. Maybe we can add 2 to the 0, it will be 2 and 3, or we can count them 1 and 2, so the new point will be here. Whatever the way you find you are more comfortable with applying. Okay, you see the figure here, when we move it, it perfectly matches. Okay. Exercise 3. We will move this figure 5 points down. You will start by this point. You will subtract 5 from 3, so we have negative 3 and 3 minus 5. So it will be negative 3 and 0. So the new point will be here, negative 3 and 0. And this point here, 0 and 0. You will take 0 and 0 minus 5. So the new point will be 0 and negative 5. So the new point will be here. And the last point, which is 3 and 3. Okay, 3 and 3. So we'll subtract 5 from the y. So we have 3 and 3 minus 3. So it will be 3 and negative 2. So the point will be here, 3 and negative 2. See here, this is the new figure. And if we move the previous figure 5 points down, 1, 2, 3, 4, 5, it will be in a perfect match with the new figure. Okay, exercise 4. Move the figure 3 points to the left and 4 points up. So we have double motion here. We will move it 3 points to the left and 4 points up. 3 points to the left, means we will subtract 3 from x and we will add 4 to y. Okay, you'll start by this point, 0 and 3. So we have 0 minus 3 to move it 3 points left, and 3 plus 4 to move 4 points up. So the new point will be negative 3 and 7. So the new point will be here. Okay, let's do the other point by the motion. We'll move 3 points left, 1, 2, 3. Okay, so we'll be at 0, and 4 points up, 1, 2, 3, 4. So we'll be here at 0 and 4. Okay, so the new point will be here. Okay, use whatever way that suits you. Maybe you can move them in the coordinate plane, or you can add number to the, to the point itself. Okay, so you'll move the old figure here, 4 points up, then 3 points to the left. Divisibility rule. Okay, to say that a number is divisible by 2, the last digit must be even. So let's see here, the last digit, it's 8. It's an even number, so it's divisible by 2. Okay, here the last digit, 3, 6, 9. 9, is it even or odd? No, it's odd, so it's not divisible by 2. Okay, for the 4, you must see the last 2 digits, not only the last digit, it must be in table 4. Okay, let's see this number, 124. 24 last 2 digits, are they in table 4? Yes, they are, so they are divisible by 4. Okay, let's see this number. The last two digits are 30. Are they in table 4? No. So this number is not divisible by 4. Okay, 3. To say that a number is divisible by 3, the sum of each digit must be in table 3. So their sum must be in table 3. So we have here 327, 3 plus 2 plus 7. They will be equal 12. They are in table 3, so they are divisible by 3. And let's see this number, 248, are their sum. 2 plus 4 is 5, and 5 plus 8 is 13. It's not in table 3, so they are not divisible by 3. Yes, 2 plus 4 is 6, and plus 8 is 14, not 13, I'm sorry. Okay. Okay, for 6, it must be divisible by 2 and 3, both. So in 2, it must be ending with even number, and also their sum must be in table 3. So both must be in the number to be divisible by 6. Okay, for 5. For a number to be divisible by 5, it must end with 5 or 0. Okay, and 10, the number must end with 0 only. Okay? Okay. Exercise 5. Choose the number divisible by 2. Let's see here. We have the 4. Its last digit is even. 14, 30, 50, 70, and 10, and 102. 6, 8, 16. Okay, choose the numbers that are divisible by 5. Let's see what are the numbers that end with 0 or 5. So we have 30, 50, 70, 10, 5 of course, 65, 25, and that's it. Okay, angles in a triangle. Okay, for any angle in any triangle in the world, the sum of each angle must be 180, whatever it is. Okay, so let's see here. If it's A and B and C plus each other must be equal 180. X, Y, and Z 180. Any triangle you see in the world, the sum of each angle must be 180, exactly 180. Okay, okay. Let's see the type of triangles. We have equilateral triangle. They are, all of the sides are equal, so all of the angles must be equal. So when it's equilateral, so the sum is 180. If we divided 180 by 3, so it must be 60. So you see here, it will always be 60 if we are talking about an equilateral triangle. Okay, for isosceles triangle, 2 sides only are equal, not the 3 sides. And by the way, so you will have also 2 angles that are equal to each other. Okay, so the isosceles triangle, 2 sides only are equal and 2 angles only are equal to each other. Okay, For the third type, it's a scale triangle, so no sides are equal to each other, and also no angles are equal to each other. Okay, find the missing angle. We have a triangle here. I want you to know, if you see the square sign here, you must know that this is 90 degree. Okay, now you won't have to write it. You must know that if you see the square, then this angle is 90 degree. So we have 90, 30, and A. Okay, so we have 180 equal 90 plus 30 plus A, and the sum must be 180. To get 180, we get subtracted from the 90 and from the 30, so A is equal to 60. Okay, so we have this isosceles triangle here. Two angles are 40, so to get the value of x, we will subtract 180 from 40 and 40, so the angle x will be 100 degree. Okay. Check whether the shape is a triangle or not from its angles only. So you can't see the shape, but you can only see the angles. So let's see this. Remember what I said about the triangle, that the sum of its angle must be 180. So if we add them, they are 180. Then they are a triangle. Okay, let's see. We added them. They are not 180, so they are not a triangle. Let's add those. They are not 180, so by the way, they will not be a triangle. And those, they are 180, so they are a triangle. And those, triple 60, you know, without calculating them, they are a triangle. And also an equilateral triangle. Okay. And this one, when you see 250, you know it's not a triangle from the first look, you know, because of course it won't be 180. So it's not a triangle. Okay. We must find the angle G. Okay, let's see here. This is a rectangle, so all of these angles here are 90, so we have 90 and 40. We can find this angle easily, as we will subtract 180, subtract 40 and 90 from the 180. So you'll have 180 minus 90 plus 40, so it will be 50. And this angle, you know, all of these angles here must be equal to 180. So they share the same line. So this angle here will be equal to 180 minus 90 plus 50. This angle and this angle plus each other minus 180 to get this angle. So it will be 40. So to get finally to get the G, we have 40 here and 90 here. So 180 minus 90 plus 40. So the angle will be 50. Okay, and the last exercise here, exercise 10, they want us to find the angle G. So we have 94 degree and 42 degree. This is an isosceles. You see this mark? This is an isosceles triangle here. So 42 must be the angle here without even calculating it. But we can calculate it and it will be 42 also. Okay. So this is here. This is an angle around the point. So we have 42 and 270. Of course, this angle will be 360 minus the sum of all other angles. So 360 minus 42 plus 270, as those are angle around the point. Their sum must be 360. So the angle here is 48, as 360 minus all of them is 48. So of course the G will be 48 also. This is an isosceles triangle. See you in the next session.